Welcome to our first lesson in triangles. So, first we'll be dealing with the congruent triangles. So, what is meant by congruent? Equal in all respects are figures whose shapes and sizes are same. So, we are talking about congruent figures. So, what is the shape should be same. Size or area both are to be same. Two figures may be having the same. So what do you mean by same shape? Suppose one is a rectangle, another is a square. They are not congruent. So one is a rectangle, other figure also should be same, and all the length should be same, size which should be same, the angles, each corresponding angle should be same, and area should be same. So not only one, each side, all sides should be same. Area should be same shape, length, breadth or width or area, all should be same. So a rectangle and square may be of the same area, but even angle will be same, but size will not be same. So they are not similar. So congruent means equal in all respect, angle, size, shape, length, everything, area. So what is the criteria for congruence of triangles? So if two triangles here, for example, of the same length, same angle, then the two triangles are congruent. So we'll study various aspects of this and how we can prove congruent and use that congruence triangle property. Next, what is the criteria for congruence of triangles? First axiom is SAS congruence rule. It is called side angle side congruence rule. Two triangles are congruent if two sides and included angle of one of the triangles are equal to the two sides and included angle of the other triangle. So we'll repeat it. Two triangles are congruent if two sides. So we'll take example, any two sides. Suppose this side is equal to two different triangles, and the second side, any side is equal to the second triangle. Suppose this is called included angle of one triangle or equal to the two sides and included angle of the other, then the two triangles are congruent. This is the first axiom called SAS congruence rule. So this rule is applied to prove all other theory. So this is an axiom. So how we can get the proof? Just take two triangles, just overlap each other. How it comes? The one side will coincide with the one side of the other triangle. This angle is same. So the second side will coincide with the second side. So third side will automatically coincide. This is an axiom. This can be proved practically. So this axiom is used to prove other conditions. So we did not prove that all the three sides of the triangle are and all the three angles should be same, and so hence it is similar, congruence like that. So if two sides and one included angle is there, then the two triangles are congruent. The first theorem and axiom. So with this, this axiom. So we have to remember we will be using it to prove all other subsequent proofs. So next is ASA congruence rule. Two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and included side of the other triangle. So in this, what exactly it means? So it is ASA congruence rule. Angle, side angle. So how we will read? First angle, side. For example, let us take these two angles are equal. Then this side, these two sides are equal. The triangle we have marked. Third angle is, so these two angles are equal. We will mark with 2. So what this ASA congruence rule says, the triangles are congruent if two angles and included side, included angle. In the previous axiom, it is two side and included angle. Now it is two angle and included side of the other triangle. So we will just see the theorems and then we will try to prove one by one. So the third one, next one, with these two, we have got two rules in hand. What is the third one? Okay, third problem is AD, just see the diagram, AD and DC cuts each other. And AD, AB and BC are AD and BC are equal, perpendicular to a line segment AB in the opposite direction. Show that CD bisects AB. So you see the diagram, AD is equal to BC, that is given. So first put AD is equal to BC given, and equal perpendicular to a line segment AP in the, so AB is a line is perpendicular to both AD and BC. So these two angles DAO, so angle DAO is equal to angle OBC is equal to 90 degrees. So now join this DC. What about these two angles? They are just opposite angles. DOA is equal to BOC. Opposite angles. So what he says, show that CD bisects AB. So CD bisects AB. So bisects AB means AO, to prove that AO is equal to OB. So the second theorem we will apply in this. So this triangle DAOC and this OBC, these two angles are equal. These opposite angles are equal. What about the third angle? So these third angle also is equal to each other. Why? So ODA angle is equal to 180 degree minus angle A minus angle O. Similarly, angle BCO is equal to 180 degree minus angle B. These two are same, minus angle O, or this is 180 degree minus 90 minus angle O. The third angle, when two angles of a triangle are equal to the other two angles of a rectangle, third angle is equal. So what we found now? We will mark now. So this triangle is this angle is equal to this angle. So triangle ADO is congruent to triangle BCO. Why? So we will apply ASA congruent rule. So what ASA says? One side DA is equal to BC and two angles. So you should notice the way of writing. When I say it's ADO, the other side is BCO. It ends with O because see AD is equal to BC. It should come in the same order. For example, the order you should not change. How to know the order? We can check like this. See, AD distance is equal to BC. So what is the conclusion? Therefore, so this CO is equal to OD. The same order we can say this one, these two. So what is the now? What about AO and OB? So AO if you take here, it's BO. So therefore AO is equal to BO distance. Same order. AO you take here BO. Therefore O bisects AB. What about angle? Now angle also like that. When ADO is equal to BCO, the same order. You take some other angle. What about DAO? DAO you take. Same way it is CBO. So we'll move to next problem. ABC is a triangle in which altitude BE and CF, two sides AC and AB are equal. So what is ABC? Is a triangle. Just draw any triangle ABC which altitude BE. So when B is altitude means this angle BEC is 90 degree and CF Is altitude means, of course, this side or one this side or this side, both are 90 degrees. So it is also marked. Given is the altitude B and CF to the sides are equal. The altitudes are equal. So it is CF. So what is you write? What is CF is equal to BE, altitudes. So CEB is equal to CFB equal to 90 degree. Of course, you can write this side also, CFA or BEA, that is also 90 degrees. So what is that to prove? Show that the triangle ABE, what is the triangle? ABE is congruent to triangle ACF. These two triangles are congruent. That we have to prove. So, we will take these two triangles. Now take triangle BCF and BCE. These two triangles you take for consideration. These two triangles BCF and BCE. So we know this BC is common. BC is common to both triangles. What about C? CF is equal to B given. CF is equal to BE. So if you come take triangle BCF and this should be CBE. So end with F means E. So this should be CB in that order. CF is equal to BE given altitudes. So two sides are over. So instead of taking triangle BCF, we will take triangle the ABE and ACF. Directly we will take that, not that. Okay. We take triangle AEB and AFC. Oh, that directly we can prove. See, in this, we'll use the angle properties. Angle A is common for these two triangles. Angle A is common. One more, angle F is equal to angle E is equal to 90 degree. So the third angle also is equal. So CF is equal to BE given. So ASA congruent rule is two triangles. Triangles are triangle AEB and AFC are congruent. AB says AB. We can write the same order, no? AB if you write here, or if you write ABE, here you should write AC. Yeah, the same order we should write. And ACF are congruent. See, note, if you change this order also. So now we can check the answer this way. How? See here, CF is equal to BE. In that order, it should come. Angle F. So angle F is equal to angle E. Should be in the same position. The position should not change. So A is common. It is the same place. It should be in that order. So what is that? If you start with A, next this is B here, E here, A, C, F. So AB is equal to AC. Actually, this AB is equal to AC. Actually, this is an isosceles triangle. These two, angle B is equal to angle C. Because this is an isosceles triangle. So AB, how AB is equal to AC? See the same. If two triangles are common, this AB is equal to AC. Therefore, AB is equal to AC. The same order we can write. B is equal to CF. EA is equal to FA. Like that. So we'll just see. Next, go to next problem. In this ABC and DBC, two isosceles triangle on the same base. So what do you mean by isosceles triangle? So angle ABC is equal to angle ACB. Similarly, angle DBC is equal to angle DCB. These two triangles are isosceles triangle and are the same base PC. Now what we have to show? Show angle ABD is equal to angle ACD. It is very simple. So these two angles are equal. Now, so we have to write the same thing. Angle ABC is equal to angle ACB. Angle CBD is equal to angle BCD. So if we add both, we get angle ABD is equal to angle ACD. We have to add these two angles. So isosceles triangle means two angles are equal. On the same base. So BC is the base. That's why those two, we are telling angle B and C are equal with the same base. Base is BC. Okay. Next problem. Triangle ABC is an isosceles triangle. So we are seeing some properties of isosceles triangle, which AB is equal to AC. AB is equal to AC marked here first. It's an isosceles triangle. So now we are going to prove the triangle. So what is that? BA is produced to D such that AD is equal to AB. So these three are equal. Show that the angle BCD is a right angle. BCD is a right angle. So how we will prove? The first part, what is given? Angle ABC is equal to angle ACB, and angle ADC, or we can tell angle BDC, we can tell. If you can tell as angle ADC or angle BDC is equal to, so this is also an isosceles. These two angles are equal. It's equal to DCA. Because it is isosceles triangle. If you add both, what's happening? Angle ABC is same as DBC, or it's angle B simply. It's angle B plus what is BDC? It is simply angle D is equal to, if you add here these two, you get angle C, total angle. So we know angle B plus C plus D is equal to 90 degree. So B plus D plus C is equal to, sorry, if we add the three angle of a triangle, it is 180. So B plus C is equal to C. So we can write as C plus C equal to 180 degree, or angle C is equal to 90 degrees. So B plus D is equal to C. If you replace angle C, so with this, we have come to end of this chapter. Thank you for listening this patiently. Now, in this proof of this ASA congruence rule, we will take in the next class. Okay. Thank you.